Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, the last of this section, we're going to talk about the change of base formula. So where this is really important is that your calculator only comes with two logarithms built in. We have log x, which is the common logarithm whose base is 10, and we have the natural logarithm of x, which is the logarithm whose base is e. Now, if we need to calculate a logarithm that's not one of those two, we're kind of stuck. However, the change of base formula can be used to convert any logarithm with any base into one of those two logarithms. And the formula goes as shown here. Log base a of x can be rewritten for any possible base b, any positive number, log base b of x divided by log base b of a. And so that means that we can do log x divided by log a, or we could do the natural log of x divided by the natural log of a. The original base ends up in the denominator. The original argument ends up in the numerator. Now, before we do this, let's talk about how we know that this works out. And so the proof here will start with y equals log base a of x. I'm going to show that I can convert y to also be the expression on the right-hand side. Convert this to exponential form, a to the y power equals x. Now we can take the logarithm base b of both sides. Log base b of a to the y power equals log base b of x. Whatever we do on the left side, we do on the right side. Now we've got that power rule for exponents that allows us to move this y out of the numerator, out of the exponent, and that gives us y times log base b of a equals log base b of x. And then I can finish by dividing both sides by log base b, oops, that's not written very well, log base b of a. So I've shown that y is equal to the left side of the formula and the right side of the formula. Therefore, the two sides must be equal to each other. So log base a of x is equal to log base b of x divided by log base b of a for any positive number b. Now, let's use this formula. And I'm going to start with an example that we don't need the formula for, just to show you that it works. So log base 2 of 32 is equal to 5 because 2 to the 5th power equals 32. But we'll rewrite it in terms of the common logarithm and the natural logarithm and show you that all three methods give us the same result. So we'll do log 32 divided by log 2, and we'll also do the natural log of 32 divided by the natural log of 2. Now you shouldn't do both of these, right? You should pick one and do it. We're going to use ln a lot more than log, so I would recommend just using the natural logarithm, but you can use either one as long as you use it in both the numerator and denominator. So let's go to the Desmos calculator, and I want to start with log 32 divided by log 2 for the common logarithm. Function log main 32, there's the numerator, divided by, you could also push the fraction button, a over b, to get a fraction and type it. But when you type divided by, it makes a fraction for you. In the denominator, function log main 2. And we notice on the right-hand side that we get 5. If I use natural log, I'll get the same result. Function natural log main 32. Divided by function natural log main 2, and again we get 5. So we got 5 either way. We only have to use one of them. Actually, If you notice that 2 to the 5th power is 32, that's much better. But either one of these will work in the calculator. And again, I'm going to use natural logarithm because we use it in a lot of equations that we solve moving into the next section or two. All right, B, log base 6 of 50. So I know that 6 squared equals 36. That tells me that log base 6 of 50 has to be greater than 2 because 50 is greater than 36. I also know that 6 to the 3rd power equals 216, and so the logarithm's got to be smaller than 3. So we're looking for an answer somewhere between 2 and 3, and we can approximate that by finding the natural logarithm of 50 and dividing that by the natural logarithm of 6. Function, natural log, main, 50, divided by function, natural log, main, 6. And that is 2.183. Oh, I needed 4 places this time. So that was 2.1833. As expected, it was between 2 and 3. Now, the next one's going to be negative because whenever we take the logarithm with a base that's greater than 1 and an argument that's smaller than 1, the exponent, the logarithm, has to be negative. Natural log of 0.5. So the argument always becomes the argument in the numerator divided by the natural logarithm of 9. The log of the base is always in the denominator. Let's check this one out. Function, natural log, main, 0.5. Tap behind that, divided by function, natural log, main, 9. And we're looking for 4 places here. I've got negative 0.3154. The next number 6 is big enough to round up. So negative 0.3155. Okay, that's it for the change of base formula. Be sure that you understand the proof of that formula. It's a big thing moving on in mathematics, being able to verify that a formula is true. And again, when it comes time to using the change of base, try to stick with one logarithm and use that exclusively. Here, I've used the natural logarithm, but you could also use the common logarithm. All right, I'll see you in the next section.